regulate and integrate almost all physiological functions are the nervous system and the endocrine system. The information transmitted by the nervous system in the form of electric impulses is conducted rapidly in the neurons. The signals from endocrine glands or ductless glands are communicated by means of chemical substances called hormones. The hormones are secreted into and can stream from their point of origin to the target organs or tissues. In the target tissues, the hormone's action is manifested. A hormone may be defined as a chemical substance synthesized by the cells of endocrine gland and carried by blood to the site of action where it exerts its physiological effects. Hormones are considered as chemical messengers. Function of endocrine glands. Endocrine glands play an important role in maintaining the consistency of internal environment, and hormones integrate and regulate various physiological functions. They regulate the general metabolism, the metabolism of carbohydrates, proteins, fats, minerals, and water. The endocrine glands also controlling the reproductive functions of hormones prepare the body to meet emergency and stressful situations. The hormones are also responsible for intercellular communication. Each endocrine gland may secrete excess quantities of its own hormone. However, once the normal physiological response is over, this information is fed back to the endocrine gland. As a result, its secretion decreases or inhibited. Conversely, the hormone is subnormal and the physiological effects or responses are reduced. The information is taken to the gland and it secretes the hormone at an increased rate. Thus, homeostatic equilibrium is restored. Hypothalamus. Hypothalamus represents the central part between the nervous system and endocrine system, though pituitary is designated as the master gland controlling the functions of other endocrines. The pituitary itself is controlled by the hypothalamus. The above control is effected by means of releasing hormones or factors and inhibitory hormones or factors. The hypothalamus is connected to the posterior lobe of pituitary tissues and to the anterior lobe of pituitary by the releasing factor from the hypothalamic cells reach their pituitary through their axons. The hormones from the pituitary enter the bloodstream. Pituitary gland. The pituitary gland is otherwise called hypophysis. It is located at the base of the brain. It is approximately 1 centimeter long, 1 to 1.5 centimeter wide, and 0.5 centimeter thick. It weighs about 500 milligram. Anatomically, the pituitary gland is divisible into anterior adenohypophysis and posterior neurohypophysis. The adenohypophysis consists of three lobes or zones, namely pars intermedia, pars distans, or pars tubularis. The anterior lobe or adenohypophysis is embryologically derived from roof of the mouth as a dorsal pouch. The neurohypophysis, on the other hand, originates from the floor of dancephalon as a downward growth. The hormones of anterior pituitary. The adenohypophysis is responsible for secretion of sex tropic hormones or tropins. They are growth hormones or somatotropic hormones, thyrotropic hormone or adenocorticotropic hormone, follicle stimulating hormone, luteinizing hormone, prolactin, leukotropic hormone. Metabolic function of the growth of hormone. Growth hormone is responsible for various general metabolic functions. It affects the diverse spectrum of integrated metabolic reactions which participate in the overall process of growth. Growth hormone influences carbohydrate, proteins, and lipid metabolism. Growth hormone stimulates both the formation of cartilage, chondrogenesis, as well as bone osteogenesis. It causes the retention of minerals such as nitrogen, potassium, phosphorus, sodium, etc., useful for growth. Deficiency of growth hormone or hyposecretion in children results in retarded growth, dwarfism. The premature arrest of skeletal development causes dwarfism. The adult dwarfs will grow to a height of only 0.9 to 1.2 meters. They never attain puberty or do not develop secondary sexual characters. Of growth hormone results in overgrowth of the skeletal structure, and a person may reach a height of 7 to 9 feet. Gigantism. The excessive growth hormone in adults also results in the increase in thickness of lower jaw and disproportionate overgrowth of feet. The above condition is known as acromegaly. Thyrotropic hormone or thyroid stimulating hormone. Thyroid stimulating hormone is glycoprotein with a molecular weight of 28,000 daltons. It is made up of 211 amino acids. The specific target organ for the TSH is the thyroid gland. It stimulates the thyroid to secrete the thyroxine. There exists a negative feedback mechanism between the circulating level of thyroxine and the hypothalamus releasing factor. When the thyroxine is less in blood, the hypothalamus produces more thyroid stimulating releasing factor, which on reaching the pituitary stimulates secretion of TSH. TSH on reaching the thyroid stimulates the thyroid to secrete more hormone. Conversely, when there is excess thyroxine in blood, the production of thyroxine is controlled by non-secretion of releasing factor from hypothalamus. Adrenocorticotropic hormone, it is a protein hormone. ACTH also functions by the negative feedback mechanism and stimulates the adrenal cortex and its secretion. Its other functions include the stimulation of formation of melanin pigment in the melanocytes of skin, stimulation of insulin secretion, and metabolization of fats from adipose tissues. Follicle stimulating hormones FSH. It is a gonadotropic hormone that directly stimulates the gonadal males and females. The human FSH is a small glycoprotein. The target organ for FSH in the females are the ovaries. It promotes the growth of Graafian follicles and thereby increases the total weight of the ovary. It also promotes the secretion of estrogen in males. The target organs for follicle stimulating hormones are the testes. It directly the germinal epithelium of the seminiferous tubules and augments the rate of spermatogenesis. Luteinizing hormone or interstitial cell stimulating hormone. Human ICSH or LH is glycoprotein and females the LH stimulates the ripening of ovarian follicles and induces ovulation in males. The LH or ICSH especially affects the Leydig cells or interstitial cells of the testes and stimulates the synthesis and secretion of the male hormone androgen and testosterone. Prolactin or leukotropic hormone (LTH). Prolactin is called by several names such as leukotrophine, leukotropic hormone, lactogenic hormone, memotrophin, etc. It is protein hormone. Its main function is stimulation of milk formation of initiation of lactation parturition in mammals. It is also stimulates the corpus luteum to secrete the progesterone. Prolactin together with estrogen stimulates the growth of mammary glands and makes it ready for milk secretion. Hormones of neurohypophysis. Neurohypophysis are the posterior pituitary secretes oxytocin and vasopressin. Oxytocin contains a sequence of amino acid residues. The term oxytocin refers to rapid birth. This hormone directly stimulates the smooth muscles of uterus and causes the contraction and helps in the delivery of fetus. Another major physiological role of oxytocin is the secretion of milk from the lactating breast. Oxytocin stimulates the myoepithelial cells which surround the alveoli and ducts of mammary gland. The contraction of myoepithelial elements in turn expels the milk from the alveoli of the breast into the larger ducts or sinuses. From the sinuses, the milk ejected out. The vasopressin, it is otherwise called as the antidiuretic hormone. Its main function is the retention of water inside the body by acting on the renal tubules. It increases the permeability of the distal tubules and collecting ducts and promotes the reabsorption of water from the renal filtrate. It causes the contraction of all blood vessels and increases the blood pressure. It also helps in the retention of urea. Iodine deficiency leads to diabetes insipidus. The symptoms of diabetes insipidus are excretion of large volumes of dilute urine. Polyuria combines with an intense thirst, leading to the consumption of large quantities of liquid. Polydipsia, thyroid gland, and thyroxine. Thyroid gland consists of a pair of lobes which lie one on either side of larynx in the neck region. The paired lobes are joined by a narrow anterior bridge of glandular tissue called isthmus of the thyroid. The lobes of thyroid in turn are divided into many lobules. Lobules consist of follicles. The follicles are called acini, sinus singular. Each sinus is lined with glandular cubical epithelial cell. The cavity of a sinus is filled with a gelatinous material called colloid, which contains thyroxine. The hormone thyroxine is an iodinated hormone. It contains 65% iodine. The amino residue in thyroxine is thyroxine and tyrosine. Function of thyroid. Thyroxine stimulates normal growth and development, especially the skeletal and nervous system. It controls rate of cellular oxidation and skeletal and nervous system. It controls the rate of cellular oxidation and increases the basal metabolic rate. The basal metabolic rate BMR is defined as the amount of heat produced in body in a given time in complete state of physical and mental rest at 20 degrees centigrade at room temperature. Action of thyroxine. This hormone is very essential for the development of nervous system, particularly at the time of birth, of all except brain, gonads, and necessary sex organs, lymph nodes, spleen, and lungs. The most important function is to increase the absorption of glucose from small intestine. This hormone reduces serum cholesterol level. It promotes protein anabolism and helps in growth. It increases heartbeat rate, force of contraction, and pulse pressure. Presence of optimum level of thyroxine and blood maintain efficient muscle function, and the optimum level of thyroxine and blood is also necessary for normal gonadal function. Hypothyroidism. The physiological effect due to the deficiency of thyroid hormone is referred to as hypothyroidism. It is manifested by iodine deficiency and simple goiter, cretinism, and mesoedema. The dietary intake of iodine becomes inadequate below 10 micrograms per day. The synthesis of thyroxine is impaired. As a result, the thyroxine level falls in circulation and secretion of thyroid stimulating hormone increases, causing the hypertrophy of thyroid gland as a consequence. The thyroid enlarges to enormous proportions. This is called simple goiter. This condition is also called endemic goiter. It is caused due to lack of iodine in the size of different regions. Cretinism. Cretinism is found in children who are deficient thyroxine hormone from the time of birth. The characteristics of cretinism are retardation of mental growth to extreme degree, dwarf stature, protruding tongue, and abdomen, low basal metabolic rate, subnormal body temperature, retardation in skeletal growth, and arrest of pubertal sexual maturity. Myxoedema. Myxoedema in adults is a syndrome with the following characteristics. Lobium are dry, coarse, scaly skin, puffy and bloated face, and sparse hair, hoarse voice, slow speech, slow thought processes, poor memory, etc. Other symptoms are muscle and fatigue, blood pressure, anemia with increased serum cholesterol, etc. Hyperthyroidism. The hyperfunction of thyroid gland results in grave disease. Grave disease is characterized by increased BMR with increased pulmonary ventilation, protrusion of eyeballs from the sockets, increased heartbeat rate, nervousness, emotional instability, weight loss, increased blood glucose, and decreased serum cholesterol, derailment of sexual function, etc. Parathyroid glands. In men, the parathyroid gland are small oval yellow-brown bodies found attached to posterior surface of the thyroid gland. The parathyroid gland secretes two hormones, namely parathyroid and calcium. Parathyroid. Purified parathyroid is simple polypeptide chain. It has short duration of biological activity. The half-life of the hormone is of about 20-30 minutes only. Physiological effects of parathyroid. Parathyroid regulatory effects at three different loci in the body, namely the skeleton, kidneys, and gastrointestinal tract. In skeleton, the hormone directly acts upon the bone tissue, stimulate the activity of osteoclast cells, bone-destroying cells. Under influence of this hormone, calcium is released from the bone matrix into the circulation. As a result, plasma calcium level increases, thus it helps the skeletal remodeling. In kidneys, parathyroid induces a marked increase in phosphate excretion. In the gastrointestinal tract, parathyroid stimulates the absorption of calcium and phosphate from the gut by enhancing vitamin D synthesis. As a result, more phosphate and calcium are transported into bloodstream. Its other physiological effects include its inhibitory action over the osteoblasts or bone-forming cells, bicarbonate reabsorption and reduction of urine pH, etc. Calcitonin. It is a calcium lowering hormone secreted by parafollicular cells of the parathyroid gland. It is protein. Its physiological effects are antagonistic to that of parathyroid. It inhibits bone resorption in kidneys. It inhibits the reabsorption of calcium, phosphorus, sodium, potassium, magnesium, and other ions. It decreases gastric hydrochloric acid secretion. It also decreases the insulin and glucagon secretion. Hyperparathyroidism. It is a condition where there is an increased amount of parathyroid hormone in circulation. Yes, hi. Excess secretion of parathyroid brings about demineralization of bones. The protein matrix of bone is also absorbed. These changes result in bone cyst and the elevation of calcium level in the blood. The latter causes calcification of kidneys, arteries, stomach, and lungs. Hypoparathyroidism. Removal of parathyroids causes the blood calcium levels to fall and results in tetany. Tetany is characterized by low serum calcium, hypocalcemia, reduced urinary excretion of calcium and phosphate, neuromuscular hyperstability, spasm of muscles, and cramps, etc. Pancreas. The endocrine part of the pancreas consists of specialized groups of cells known as islets of Langerhans. These cells synthesize, store, and secrete two hormones, namely insulin and glucagon. There are two kinds of cells, namely alpha and beta cells. The alpha cells produce glucagon, while and beta cells and other type of cells called delta cells are present in human pancreas. According to some investigators, the delta cells represent the transitional forms of two cell types alpha and beta. Insulin. Insulin is a protein hormone or a polypeptide hormone with 51 amino acid residues. Human insulin has a molecular weight 5,734 daltons and consists of two chains A and B, which are linked together by disulfide bridges found between two cysteine residues. Physiological effects of insulin. It decreases glucose level in the blood in three ways. It increases conversion of glucose into glycogen and deposition of it in liver and muscles. B. It increases the rate of oxidation of glucose in the tissues. C. It increases the rate of conversion of glucose into fat and facilitates storage in adipose tissues. D. It also regulates the rate at which amino acids are catabolized into water and carbon dioxide. E. Moderately, it also regulates the gluconeogenesis in the liver. This insulin reduces the glucose level in the blood. Hypoglycemia. If the insulin is not secreted sufficiently, the liver and the muscles are unable to convert the glucose into glycogen. As a result, more glucose enters into the bloodstream, raising the blood sugar level. The condition is called hyperglycemia. The excess of glucose is eliminated along with urine, resulting in a disease called diabetes mellitus. A diabetic patient excretes large amount of urine, polyuria, and consumes excessive fluid, polydipsia. He always feels hungry and eats excessively. Polyphagia. When insulin levels are low, fat metabolism is increased and fat are converted into glucose. This further increases blood glucose level and results in the accumulation of ketone bodies, ketosis. Hyperglycemia. The normal fasting blood glucose level is 70 to 110 mg per dl deciliter. Thus, this range is maintained under varying conditions of blood intake, fasting, or body exercise. After carbohydrate meal, the blood sugar reach a peak level of about 140 mg per dl. If such a high level is maintained for a prolonged time, the condition may be termed a hyperglycemia. Hyperglycemia over a long period may cause degenerative changes in several organs, leading to malfunctions and mortality. Elevated blood sugar level of 400 mg per dl or more in few days causes dehydration to coma and death. Hypoglycemia. It means a low plasma glucose concentration. This concentration can drop to very low values during fasting. It is termed as fasting hypoglycemia. It may result due to excess of insulin or level of glycemia occurs. Fasting hypoglycemia may show symptoms such as hunger, increased heart rate, tremor, looseness, weakness, nervousness, and sweating. These are caused due to activities of the sympathetic nervous system. Other symptoms such as headache, confusion, uncoordination, and slurred speech are due to availability of too little glucans to the brain. Serious brain defects and epilepsy and coma can occur if the plasma glucose concentration goes low. Diabetes mellitus. The name diabetes in Greek means siphon or running through. This term describes the enormity of urinary volume excreted by people suffering from this disease. A persistent hyperglycemia leads to diabetes mellitus. This disease may be due to deficiency of insulin or to a hypo responsiveness to insulin. In type 1 insulin dependent diabetes, The hormone is completely or almost completely absent from the islets of Langerhans and the plasma. In type 2 insulin-independent diabetes, the hormone is often present in plasma at near normal or even above normal level. The type 1 is less common. It is due to the total or near total destruction of the pancreatic beta cells. The type 2 is due to insulin resistance. The insulin target cells do not respond normally to the circulating insulin. This may result due to obesity, overeating, and lack of exercise. The insulin hyporesponsiveness can be corrected if the person reduces his or her caloric intake. Thus, dietary control without any other therapy is frequently sufficient to eliminate the elevated blood glucose level of type 2 diabetics. An exercise program is also useful since it will help to increase the number of insulin receptors. Glucagon. Glucagon secreted by alpha cells of the pancreas is a polypeptide hormone with 29 amino acid residues. Physiological action of glucagon. The major function of glucagon in the body is to elevate the blood glucose level. The glycogenolysis in the liver as it raises the blood sugar level. It is also called as hypoglycemic hormone. A second important function of glucagon gluconeogenesis in the liver, in which amino acids are used as substrates. It promotes lipolysis and release of fatty acid in the adipose tissue. The increased fatty acid oxidation leads to ketogenesis. Glucagon also stimulates myocardial contractility. Glucagon exerts a direct effect upon the kidneys and accelerates the renal plasma flow and glomerular filtration rate. Its proper balance between insulin and glucagon production is necessary to maintain proper blood glucose level. Adrenal gland. The adrenal gland or suprarenal gland is composed of an outer cortex and inner medulla. The adrenal cortex forms the major portion of the total mass of tissue of adrenal gland. In adults, three concentric zones are discernible within the cortex. 1. A thin outermost layer, zona glomerulosa. 2. A thick middle region, zona fasciculata. 3. A relatively thick inner layer, zona reticularis. In men, the cells of zona fasciculata and zona reticularis act as single unit, the main function of which is to form glucocorticoids and to a lesser extent androgens and possibly estrogens. The mineralocorticoids hormone aldosterone is secreted by cells of the zona glomerulosa. The enzymes necessary for its synthesis reside in the cells of zona glomerulosa. All adrenocorticoid hormones are steroid action of glucocorticoids. The major glucocorticoids are cortisone and certain closely related steroids. These hormones stimulate the production of glucose from non-carbohydrate sources such as fats and amino acids. Glucocorticoids also decrease glucose utilization by tissues. In general, all these effects lead to increased blood glucose level. Cortisone also acts as an anti-inflammatory agent. Action of mineralocorticoids. The major effect is on metabolism of sodium ions and indirectly potassium ions. The major mineralocorticoids hormone is aldosterone. Its most important effect is to promote the resorption of sodium ions from the renal glomerular filtrate. Secondary effects of sodium retention are an increased chloride retention and a decreased potassium retention by the kidneys. The most important function of adrenal cortex is its role in stress tolerance. Adrenal medulla. The medulla of adrenal gland differs both in morphology and physiology from the cortex portion. Both cortex and medulla are derived independently and from totally different tissues in the embryo. The adrenal medulla in the adult humans and other mammals is invested closely by cortical tissue. The cells of the adrenal medulla are large, wide, and columnar in type and are grouped into clumps around the blood vessels. The hormones produced by adrenal medulla are adrenaline, epinephrine, 2 noradrenaline, norepinephrine. The two hormones belong to a group called catecholamines. The various physiological and biochemical action of adrenaline or epinephrine are the following: contraction of blood vessels supplying the intestine, kidneys, viscera, and skin, and causes dilation of blood vessels supplying skeletal and heart muscles. 2. It increases the rate, amplitude, and frequency of heartbeat. 3. It causes relaxation of smooth muscles of the digestive tract and brings peristalsis to a halt. 4. It causes relaxation of bronchi, dilation of the pupil, closure of sphincters, and increases sweating. 5. It causes contraction of muscles associated with hair follicles and makes the hair stand on end and causes goose flesh. 6. It accelerates respiration and stimulates mental alertness. 7. It stimulates the breakdown of glycogen to glucose, thereby increasing oxygen consumption and heat production. And biochemically, it releases the free fatty acids and increases blood glucose level. 9. Adrenaline prepares an individual during emergency or stress situations. Hence, it is called fight, flight, and fright hormone. Action of noradrenaline or norepinephrine. Noradrenaline has certain effects similar to that of adrenaline. For example, both the hormones dilate the coronary vessels. However, norepinephrine causes vasoconstriction in most organs other than heart. It increases both systolic and diastolic blood pressure. It exerts a weakly inhibitory action upon contractile activity of smooth muscles in the gastrointestinal tract. However, it does not relax the smooth musculature of the pulmonary bronchioles. Norepinephrine exerts very little effects upon carbohydrate metabolism and oxygen consumption. Gonads. But testes and ovaries, in addition to their role as reproductive gamete producing organs, function as endocrine structures also. Testes. Testes in males, in addition to the germinal epithelial cells, contain groups of epithelioid cells called interstitials or Leydig cells. These cells constitute the endocrine tissues of the testes. The Leydig cells secrete the androgenic hormone testosterone. The androgens are steroids. In the normal post-pubertal males, the rate of secretion of testosterone ranges from 4 to 9 mg per day. Action of testosterone. Testosterone causes embryonic development of male reproductive organs. It develops of the secondary sexual characters of males, including physical development, hair distribution, masculine voice, and behavior of puberty. Ovary. The ovaries are paired, oblong in shape, and situated in the pelvic portion of the abdominal cavity. It releases hormones such as estrogen and progesterone. Estrogen. Under the influence of follicle-stimulating hormone from the adenohypophysis, the ovum grows and becomes enclosed in the Graafian follicle. Associated cells of the follicle produce a steroid hormone called estrogen. The estrogens are C18 steroid compounds. It is responsible for the growth of female reproductive organs and for the appearance of secondary sexual characters. Progesterone. After discharge of ovum from the Graafian follicle and after fertilization, ruptured follicle cells form a new structure called corpus luteum. It produces the pregnancy hormone progesterone. Progesterone is also synthesized and secreted by the placenta during the later part of gestation. This hormone is C21 steroid compound. Progesterone is responsible for premenstrual growth in the non-pregnant woman's uterus, development of the placenta during pregnancy, and the embedding of fertilized ovum in the uterus, implantation, relaxation. The corpus luteum of the pregnant woman secretes another hormone, relaxin. In addition to progesterone, relaxin helps in relaxing the muscles and ligaments of pelvic organs during childbirth parturition.